We now discuss the solution of a problem from the section Differential Calculus, and it is the third example in this paper on applications of derivatives. This question has appeared in the joint entrance examination main held on 24th June 2022 in the first session. The problem is, for the function f of x is equal to 4 times log of x minus 1 to the base e minus 2x square plus 4x plus 5, where x greater than 1, which of the following is not correct? Which of the following is not correct? We are given 4 options. Option A, f is increasing in the open interval 1, 2 and decreasing in the open interval 2 to infinity. Option B, f of x is equal to minus 1 has exactly 2 solutions. Option C, f prime e, the first derivative at e, minus f double prime at 2 is less than 0. Option D, f of x is equal to 0 has a root in the interval, open interval e to e plus 1. So, we are given a function. This is the function given and it is defined for all x greater than 1. And which of the following is not a correct statement? And we are given 4 options here. So, this means that in these 4 options, 3 of them are true, only 1 is not true, and we have to find out what is that statement which is not true. We now discuss the solution of the problem in detail. And first, we take the first option, that f is increasing in the open interval 1 to 2 and decreasing in 2 to infinity. Because it is an increasing and decreasing nature of the function fx which we have to decide. So, first we take fx and take its first derivative. So, and before going into that one, you note down that this function f of x is continuous in the interval 1 to infinity. Why it is continuous? Logarithm is a continuous function. Log x is a continuous function, and this being a polynomial, a second degree polynomial, and every polynomial is continuous. The sum of 2 continuous functions is again a continuous function. Therefore, f of x is continuous in the open interval 1 to infinity. So, to talk about increasing and decreasing nature of the function, so we have to first consider the first derivative. So, f prime x is equal to 4 into the derivative of log of x minus 1 is 1 by x minus 1 minus 4x plus 4. And that is written as 4 by x minus 1 minus 4 times x minus 1. So, to get the stationary points or critical points, we equate the first derivative f prime x is equal to 0. And that will give you 4 minus 4 times x minus 1 whole square is equal to 0, clearing the LCM. And this is true because x greater than 1, x minus 1 is not 0. So, therefore, this can be written. And this will imply x minus 1 whole square is equal to 1. And this will imply x minus 1 is equal to plus or minus 1. And this will imply x is equal to 2, x is equal to 0. And x is equal to 0 is rejected because x is greater than 1. So, we get x is equal to 2. So, thus we get the stationary point x is equal to 2 is a stationary point. Now, notice that f prime x is 4 by x minus 1 minus 4 into x minus 1 is greater than 0 for 1 less than x less than 2. It's very easy to see. And f prime x is less than 0 for all x greater than 2. For all x greater than 2. So, this implies thus f is increasing in the interval 1 to 2 and f is decreasing in 2 to infinity. For x greater than 2 means 2 to infinity. That's what what we got, and therefore the option 1 is true. And f is increasing in 1 comma 2 and decreasing in 2 comma infinity means what? Fx attains maximum at x is equal to 2, and calculate f max, that is equal to the value of f at 2. So go to f of x is equal to 2, you substitute and you will get 5. So that means f is increasing in the interval 1 to 2, it increases, attains maximum, that is f of 2 is equal to 5, and then decreases in 2 to infinity. That means fx is fx being continuous, and it is the path of the f of x, that is the graph, is a parabola. So that's what we can conclude. So we will discuss that at a later discussion. So let's look at our options, and we have to find out what is that statement which is not correct. And so far we have seen statement A, this option A is true. That means from these B, C, D, one of them is not true. We have to find out. So two of them are true. So in this, for a student, as a student I will think, and f prime e minus f double prime 2 calculating and seeing whether it is less than 0 or greater than 0 will be easier for me. So therefore I will go for it. Of course, B and D also I have to go. If this is true, I have to go for B, D, and so on and so forth. So I will see because this is more familiar for me. So I will go to that in the next slide. We consider option C, f prime e minus f double prime 2 less than 0. We have f of x, and f of f prime x we have already calculated. In that, put x is equal to e, you will get f prime e is equal to 4 by e minus 1 minus 4 times e minus 1. Now f double prime x, calculate minus 4 by x minus 1 whole square. So the derivative of 4 by x minus 1 is minus 4 by x minus 1 whole square minus 4. Minus 4 into derivative of x minus 1 is 1. So direct you substitute x is equal to 2, f double prime 2 is equal to minus 8. Let's see now f prime e minus f double prime 2, that's equal to f prime e is 4 by e minus 1 minus 4 into e minus 1 plus 8. And that when simplified, you will get 4 by e minus 1 plus 12 minus 4e. Agreed. Note that e greater than 2, e minus 1 greater than 1, therefore e minus 1 is greater than 0. Correct. So this is 4 by e minus 1 is also greater than 0. And 12 minus 4e greater than 0, and because 2 less than e less than 3. So how it is, I will show you in the box. So e less than 3, 2 less than e less than 3, okay, e less than 3, minus e greater than minus 3, agreed. This will imply minus 4e, and e less than 3 implies minus e greater than minus 3. Why? It is because you are multiplying throughout by minus 1, so the inequality is get reversed. So greater than minus 3, minus 4e greater than minus 12, add 12 on both sides, 12 minus 4e is greater than 12 minus 2, that is 0. So 12 minus 4e greater than 0. So this is greater than 0. So the first one is greater than 0, the second one is greater than 0. So f prime e minus f double prime 2, this is greater than 0. But in option C, it is given less than 0. Therefore, the statement that is not true is option C. So, option C is not true. So, we have to find out that option which is not true. So, those are the 4 options which I have already seen. And option C is the statement which is not true, that is which is not correct. Therefore, our answer to this question is option C, and the problem is over. It means to that the statements given in option B and option D are true. It means that. So how they are, I will show you. I will show you in the next 2 slides. I will show you B, option D are also true. Now take option D. F of x is equal to 0 has a root in the interval e to e plus 1. And we have f of x, and f of x is a continuous function. Note down first that one in the interval 1 to infinity. Now it has a root in this open interval e to e plus 1. What it suggests to me is the application of the intermediate value theorem. So why not we calculate f of e and f of e plus 1 and see they have opposite signs and apply our intermediate value theorem. So it tells me that I have to go for the intermediate value theorem. So now see, now f of e is 4 times log of e minus 1 minus 2e square plus 4e plus 5. This can be written as 4 times log of e minus 1 minus 2 into e minus 1 whole square, the terms are adjusted, plus 7. And now note that e minus 1 greater than 1, so log of e minus 1 is greater than log of 1, that is 0. Why this happens? Taking the logarithms on both sides, log being an increasing function, this happens. So e minus 1 greater than 1 implies log of e minus 1 greater than log of 1, because log x is an increasing function and log of 1 is 0. So this part is greater than 0. This part is greater than 0. So let's see further e less than 3 will imply minus 2 times e minus 1 whole square plus 7 is greater than 1. How it happens? Let us see. Let's see. 2 less than e less than 3. E less than 3 I have taken. E minus 1 is less than 2. Right. And e minus 1 whole square is less than 4. Yes. Minus 2 times e minus 1 whole square is greater than minus 8, because you are multiplying by minus 2. So the inequalities get reversed. Okay. And add 7 on both sides. So minus 2 into e minus 1 whole square plus 7 is greater than minus 8 plus 7. That is equal to 1. So minus 2 into e minus 1 whole square plus 7 is greater than 1. That means it is greater than 0. It is greater than 0. The first one is greater than 0. The second one is greater than 0. The sum is greater than 0. So that is the one. So we have taken minus 2 also with that greater than 0. Okay. So f of e is greater than 0. So now let's look for f of e plus 1. That means wherever there is x, you substitute e plus 1. So 4 times log of x is e plus 1 minus 1, 1 and 1 minus 1 minus 1 cancels. Log of e to the base e is 1, and wherever there is x, we have written e plus 1. So that will be 4 minus 2 into all that. And the e plus 1 whole square, we have expanded, multiplied by minus 2 and all that we have done here. And that reduces to minus 2 times e square plus 11. And this is certainly less than 0. It is negative. Why? E is approximately equal to 2.7. E square is approximately equal to 2.7 whole square. And that is equal to 7.29. And minus 2 times of e square will be minus 2 times of 7.29. That is greater than minus 14. Minus 14 plus 11 will be negative. That is less than 0. So what is that we have observed? F of e is positive, f of e plus 1 is negative. So they have opposite signs. Therefore, and f of x is continuous. Therefore, by the intermediate value theorem, f of x is equal to 0 has a root in this interval e to e plus 1. So f, that means the option D is true. That means f of x is equal to 0 has a root in this interval. So the option D is true. Let's go for the next option. That is option B. That is f of x is equal to minus 1 has exactly two solutions. We have f of x and f of x is continuous. And now down f of x tends to minus infinity as x tends to infinity. As x tends to infinity, log of x minus 1 tends to minus infinity. So f of x on the whole tends to minus infinity. And you can see that x is equal to 1. X is equal to 1, is an asymptote for this curve. So, and f of s, f is increasing in the open interval 1 to 2. Yes, it is increasing and attains maximum value at x is equal to 2. Okay, so the maximum value is 2. And f is decreasing in 2 to infinity. So that means the graph of this function f of x is a parabola with vertex at 2, 5 opening downwards, because minus 2x square is there, it's opening downwards, and x is equal to 1 happens to be an asymptote for that. So the graph of fx is a parabola opening downwards because minus 2x square is there, and the vertex being at 2, 5, and x is equal to 1 is an asymptote, and it looks like this. It looks like this. And the blue line is the asymptote, x is equal to 1, and this is your parabola, vertex at 2, 5, and opening downwards. Now you see any line parallel to x-axis, that is y is equal to k, where k less than 5 will intersect the parabola in 2 points, exactly in 2 points. So notice that any line y is equal to k less than 5 intersects the parabola in exactly 2 points. In particular, y is equal to minus 1 being less than 5. In particular, y is equal to minus 1 intersects in exactly 2 points. You can see here. So therefore, y is equal to minus 1 has exactly 2 solutions. So therefore, our option B is also true. So our option B is also true. So in this, A, B, D are true and option C is false, and our answer for this question is option C, which we have already declared, and that's the discussion of the solution of this problem from the differential calculus based on the applications of the derivatives. And I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.